Okay, here's the final review. The first problem says graph this equation. You can graph this by table of values, but the problem is you are not going to be able to find the vertex, okay? Because if you pick these numbers, you're going to get these values, okay? And the vertex happens to be the x value is a fraction, and so is the y value. So let me show you how I would have graphed this. I just didn't want to go through, doing this on video, right? Picked my -2, plugged it in, and I got out 18, okay? So first thing I would do on this problem is I'd find the vertex. To find the x value, you say x equals -b/2a. This is from chapter 11. We're going to have the opposite of b. It was -3, so it becomes a +3 over 2 times 3, which is 6. So we get 3 over 6, which is the same thing as 1/2. Okay, so the vertex, my first value, is going to be 1/2. Now I have to find the y. So what I do is I plug in. I didn't have enough room because I'm going into the graph. I'm going to plug 1/2 in here. It really wouldn't matter if it was 3/6, but I'm going to say y equals 3 times 1/2 squared minus 3 times 1/2. Okay, now if you can use, if you're good at fractions, you can just go ahead and just do that out, but there's no sense. You can just do this. You can say, I'm going to store 1/2 under my x. Use that store button, and I'm sorry, the glare is kind of hard for you to see. Let me see if I can tilt that. Okay, so I have stored 1/2 under the x, which you can't really see it. But then I'm going to put 3x squared minus 3x, and now it's going to kick out 0.75, which is the same, -0.75, which is the same thing as -3/4. I don't care if you use fractions or if you use decimals, it doesn't matter. Okay, so here we're going to go, this is really hard to graph because this is really small. You would say -1/2 right here, 1/2 down 3/4. That's going to be right around in there. You can't really tell on that graph. Then, if it were me, I would find the x-intercepts. Okay, now the y, or you could do the y-intercept. The y-intercept's easiest because it would be +0. Okay, so it'd be 0, 0. That just happens to be an x-intercept as well. But if you didn't know that, if you did the x-intercepts first, that means that you are going to set your y equal to 0. I do this every single time. So I'm going to plug in 0 right here. I get 0 equals 3x squared minus 3x. I'm going to factor. You can use whatever you want to, but I'm going to factor it. Oops, I can actually factor out a 3x. And I am left with x minus 1. I'm going to set both these factors equal to 0, so I get 3x is equal to 0. And I'm also going to set x minus 1 equal to 0. Divide by 3, and I have x equals 0. So this is the point 0, 0. Right here, I'm going to add 1. And I get x equals 1. So this is the point 1, 0. Okay? Because remember, our y was 0. So 0, 0 is right here. 1, 0 is right here. And that point is really off right there because it's such a small graph. So it looks like this. Okay? Actually, you probably should read, if it were me, it was easier if you do that, something like this, make that graph bigger, such like this. Okay, then it's a little bit easier to say 1/2 down 3/4 right here in the middle. Okay, so right there. Then you have your x-intercepts here, and then your graph goes like this. Okay, again, it's a curve, not a V. It opens up because this is positive. All right. Factor. I don't care how you factor it, but I look at this and go, this is a perfect square, and so is this. So I know it's going to factor as 5b plus 3, 5b plus 3. Signs are the same, and they're both positive. The only thing I have to check for is make sure it gives me 30b. 15b, outsides plus insides give me this. And now you can do FOIL just to double check, but outsides plus insides, 15b plus 15b gives us 30b. So the shortest way to write that answer is a quantity of 5b plus 3 squared. Okay. Number 3, the first thing I notice is that I can factor out a k. I'm left with 25x squared plus 10x plus 1, not a 0, a 1. Again, I notice this is a perfect square, and so is this, and that's a plus sign. So you have to keep that k. This is going to factor as 5x plus 1 squared. 5x plus 1, 5x plus 1. Because the shortcut to this is square this, and you get 25. Square this, and you get 1. To get this middle term, you multiply these two, and you get 5x, and double that, and you get 10x. Now again, you can do the box or whatever you want to do, but these are special forms right in here, so that's what I'm going to use. This one, everyone should know how to do this. They're perfect. It's a difference of two squares. They're both perfect squares with a minus sign between it. So it would be 9x plus 5y and 9x minus 5y. It doesn't matter if these two things are switched. Okay, right here, I am going to factor out a -4. Okay, I notice that this is negative, so I'm going to factor out a -4. And I'm left with a positive 6x squared plus x, because I'm factoring out a -4, minus 15. Okay, I don't care how you factor it. Some of you use AC method, some of you use trial and error, some of you use the box method. Whichever it is that you use, then you use that. -4. I know the signs are different because of that sign right there, okay? I know, I just do trial and error. I'm going to say 3x times 2x because that's what gives me, that's one thing. I could use 6x and 1x, it doesn't really matter. And then for this 15, I could do 1 and 15 or 3 and 5, but I'm going to do 3 and 5 because that's what I have taught you to use those middle ones. I know the 3 can't go here because I have got to factor out a 3 if I put it here. So I'm going to put the 5 here, and I'm going to put the 3 here. Now the plus sign is going to go here, and the minus sign is going to go here. This outsides plus insides. I shouldn't have to check the F and the L part of FOIL because this too should multiply to that, and it does. These multiply to that. I wouldn't even put them in those positions if they didn't. But outside plus insides, 9x, -9x, positive 10x gives me 1x. Now again, you guys can use the AC method or that box method, either way, okay? All right, so this one right here, I'm going to look at it, see, okay, it doesn't have anything that I can pull out of all 4 of them. There is 4, so I am going to factor this by grouping. So the first thing I'm going to do is in here, I'm going to say, what do they both have in common? They both have a p cubed. I can pull out. This gives me p cubed. If I divide this by p to the 3rd power, I get p to the 3rd power. If I divide this by p to the 3rd power, I am left with 2q to the 3rd power. Right here, I'm going to factor out a negative 5. And I have 3 q's here, and I have 6 here, so I can pull out q to the 3rd power. Oops, okay, then I have this. That's my common factor. I am left with p to the 3rd. If I divide this by that 5q to the 3rd, I'm left with p to the 3rd. If I divide this by a negative 5q to the 3rd, I'm going to get a positive 2q to the 3rd. Guys, these two things have to match. I'm going to pull those out first. I only need one of them, and I'm left with this here. Or if you want to, you can do this. You have p cubed minus 5q to the 3rd. Okay, and then this one. I don't care. It doesn't matter which order it comes in. That's just not how I do it. Okay, and this is multiplication between here. Don't put a plus or a minus sign in there. Okay. I like to pull this out first and write it, what they have in common, and then what's left over is this. But whatever you want to do, it's fine. Okay, let me get a piece of notebook paper because I'm not going to have enough room to do the rest of these. All right, number 7. I am going to distribute this times this. Just be really careful because there's a lot of x's and y's. Number 7, when I distribute negative 3x squared y times x squared, negative times a positive is a negative 3. I'm going to say x squared times x squared. I'm going to add my exponents to get x to the 4th y. Now I'm going to take this and multiply it by a negative 2xy. Negative times a negative is a positive, 6. X squared times x is x cubed. Y times y is y squared. And then I'm going to multiply it by 4y cubed. Okay. Negative 3 times 4 is negative 12. X squared, and then y times y cubed gives us y to the 4th because we add our exponents. Okay, number 8. Number 8, I know the shortcut, okay? Some of you do too. The shortcut says square the first term and you get 9x squared. The middle term is these two multiplied together times 2. 3 times 5 is 15xy. 15xy times 2 gives us 30xy. And then you square this term right here and get 25y squared. Well, if you don't know that, write this out and do FOIL. It means 3x plus 5y times 3x plus 5y, and you do FOIL. F stands for first. That gives us 9x squared. The O part is the outsides of the parentheses. That gives us 15xy. The inside is 15xy. And the last is 25y squared. We have 9x squared plus 30xy. I'm not going to erase, just takes time. Plus 25y squared. And I forgot to write my y squared right there. See how we had 2 of them? That's why on the shortcut, you multiply these and times it by 2, because we always end up with 2 of them. All right, number 9, we subtract. Okay, when we subtract, we have to have a common denominator. So in number 9, I'm going to rewrite it down here, and I'm going to go ahead and factor this. It factors as x minus 4, x plus 3. Minus 2 times x minus 4. Now, this is not a solving problem. It doesn't say solve. It says subtract. In order for it to be a solving, it would have to say equals something on the side, but it doesn't. So it's not a solving problem. It's just simplify it. We've got to combine these things. All right. So when you subtract or add, you have to have a common denominator. Well, way back when we did this, I think in chapter 7, I always told you, take your first denominator and write them down. Write it down. Then you go to your next denominator, which is the x minus 4. And you ask yourself, does it already have it? Yes, so you don't need another one. Now, the other way you can do it is you can say, what do they both have in common? They both have an x minus 4, so you write one down. This one has an x plus 3, so we've got to add that on there too, okay? So, or tack that on. So what we're going to do, or list it, I should say, I need this denominator to look like this. It needs an x plus 3. So I am going to multiply the top and the bottom by x plus 3. Okay, it's a form of 1. Let me put this in blue. Okay, so now our denominators look the same. So what I can do is I can write it over one denominator of x minus 4, x plus 3. So right here, I just have 5 because this denominator looks the same, so I just bring it down. I'm going to say minus, and when you do this, 2 times x is 2x, and 2 times 3 gives me plus 6. But what I'm doing is I'm subtracting that whole thing. When you subtract that whole thing, it changes everything after it. This becomes a negative 2x, and the 6 becomes a negative 6. All over x minus 4, x plus 3. Now I look at this and I go negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. Either way, we end up with the same thing. So now I have negative 2x, and I'm going to combine my 5 and my negative 6 to get negative 1. All over x minus 4, x plus 3. The only thing you need to do is make sure the top does not factor to see if you can simplify your fraction. And it can't, so we're done. Okay, number 10, multiply. Okay, in number 10, I'm going to do part of it up here. Well, I'll write my answer down here. You're going to say 13 times 4, that's going to give us 52, I believe. Okay, I'm just double checking, it's late at night. And my calculator is dying, but 13 times 4, it does give us 52. Okay, so far so good. 52, I'm going to multiply my x cubed times x to the negative 1. I add those exponents. 3 minus 1, or 3 plus a negative 1, gives me x squared. And y times y to the second gives me y to the third. And that's it. Just remember, you always want your exponents to be positive, and they are, so that's fine. I don't know why all of a sudden I'm going to start boxing my answers in, but oh well. Okay, number 11. Number 11, we have x minus 1 times x squared minus 4x plus 1. Okay. This is why I hate to talk about FOIL, but I mean, that's what everybody does when it's a binomial times a binomial. But what you're going to do is, now you have a binomial times a trinomial. You have to take your x and multiply it by everything inside the other parentheses. So this is going to give us x cubed minus 4x x squared plus 1x or just x. You can put 1x, there's perfectly fine. Then I have to multiply this negative 1 by everything in the other parentheses. So I get negative 1x squared or negative x squared. Negative 1 times a negative 4 gives us a positive 4x. Negative 1 times a negative 1 is negative 1. Now we combine our like terms. Now again, you can put a 1 here and a 1 here. That's perfectly fine. We just don't write it usually. We get x cubed. Now we get negative 4x squared, negative 1x squared to give us negative 5x squared. Positive 1, positive 4, positive 1x and positive 4x gives me positive 5x. And then minus 1, and you're done. We cannot do anything more. Notice I go down in my exponents. All right, number 12. It says simplify. And we have 2x cubed. I'll move this in just a minute. Raised to the 4th. All over x to the 15th. Hold on, I gotta have kind of a cushion underneath my paper, because otherwise the desk has all these little lines in it. Okay, so here's what I want to do. I have to take care of this first. Now, don't forget, a lot of you will go, okay, raising a power to a power, you multiply your exponents, but don't forget, this 2 has an exponent as well. It's just a 1, we just don't write it. So now all of a sudden we multiply our exponents when raising powers to a power. So we have 2 to the 4th, x to the 12th, over x to the 15th. All right, now there's a couple ways to do this problem, but the way your book will explain it is this way. First of all, 2 to the 4th power gives us 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, because we're dividing, they are going to tell you to subtract your exponents, which this is perfectly fine. And so we get 16, x to the negative 3rd. The problem with this is you do not want negative exponents. This 16 has a positive 1 as an exponent. We just don't write it. So we're going to keep that on the top. And this is going to go to the bottom, and the only thing it's going to do is change that negative exponent to a positive exponent. And that's it. Okay. Now, because that's not how I do, I mean, I do it that way, but I know it's going to end up this way. So what I do is if my exponents are all positive over here, I just go, there's 12 x's on the top, there's 15 on the bottom. We have 3 more x's on the bottom. So it's 16 over x to the 3rd. Both of them work. My shortcut this way doesn't work if one of these is negative. Okay, so 13, we're going to subtract. You're going to say negative 6x cubed. This paper back over here. I don't know if you'll be able to see it or not. Number 13. That's up here. There it goes. Negative 6x cubed plus 7x. And then I'll move the paper back up. Minus 2x plus 5 minus 5x cubed. I'm sorry if I work any of these wrong or I write it down wrong and don't catch it. I don't have you guys to correct me. So anyway, this first one's going to stay the same. The second one, however, everything that follows the subtraction sign, all these signs change. Not just this one. This one's going to change. This one is, and so is this. So I'm going to get minus 2x minus 5 plus 5x cubed. Now you can think of this as, I just change all my signs and I'm done. But you could say distribute this negative sign. Negative times a positive is a negative, negative times a positive is a negative, negative times a negative is a positive. Or you could say there's a 1 there and distribute the negative 1. Any way you want to look at it, it is fine with me. I don't care. Some of you like to add the opposite. If you're going to add the opposite, okay, you have to add the opposite to all of them. Add, that becomes negative, that becomes negative, this becomes positive. I don't care how you think about it, however it is that you want to do it. Let's start with our highest exponent, which is going to be x to the third. Negative 6 plus 5 gives us negative 1 x to the third. We really don't need that 1 there. So it's just negative x to the third. It's fine if you leave the 1. And the only thing we have is these two here. Positive 7, negative 2 gives us a positive 5x minus 5. Okay. Number 14. Number 14 is a division problem. Okay. The only thing I'm going to tell you about this is we never divide fractions. We change this to multiplication and we flip this one here. But don't try to flip and factor all at the same time, okay? It's really going to mess you up if you do that. You just make careless mistakes, and I'll guarantee you that it's a multiple choice test, but I would have, if I was making this test, one of my answers would be if you didn't flip it, okay? So be real careful. I do it like this. I'm going to factor this, however it is that I factor, okay? But when you do that, it factors as x plus 5, y plus 5, and y minus 4, okay? That's the top. This one down here, y plus 5, y plus 3. This one here is a difference of 2 squares. Y plus 4, y minus 4. And this one right here, y plus 3 and y plus 7. Now, I just know how to factor. Some of you have a harder time factoring, okay? So you're going to have to use AC method or the box method. I hope I can remember that. I'm just going to show you how to do the box method for that one right there, just as a reminder, okay? So on number 14, well, actually it's not number 14, it's just a problem, okay? I'm factoring this y squared plus 10y plus 21. Okay, so here's what you do, that box method. Oops. I don't really need that many. I just need a couple lines. Okay. Okay. Here's what you do. You put this y squared right here. You put your 21 right here. Now, similar to what you would do in AC method, is you take your a and you multiply it by your c. So your a times c gives us 1 times 21, which gives us 21. Then you've got to figure out what multiplied will give you 21 will add to give you 10. So you could say 1 times 21, but that's going to add to give you 22, okay? So then you say 3 times 7, that gives us 10, okay? So we're going to replace 10y with 3y and 7y. Now these also could be negative, like you could have used negative 3 times negative 7, but that would add to give you negative 10, so that's why we didn't need that, okay? All right, now how do you factor once you have that, okay? Well, we're going to go row by row, then column by column. What can I factor out? what do they both have in common? Well, they both have a y in common. So right here, what do both of these have in common, which is 7? Then we're going to go columns. Okay, this column right here, they both have a y. And now we do this column here, they both have a 3. And because they're positive 3, that's a plus 3, and this would be a plus y plus 7. So this factors as y plus 3 and y plus 7, or vice versa. Okay? And that is where I got, I did the same thing. Okay. Now, all I did was factor them first because I'm really lazy. I didn't want to write everything back over. Okay? So now I'm going to go to dividing it. I am going to, for number 14, okay, I am going to write this over this, okay, because the first one stays. So I'm going to keep the first one, and I'm going to write the factored form, y plus 5 times y minus 4 over y plus 5 over y plus 3. Okay, so all I did was I rewrote this over. Now you change this to multiplication, and we are going to flip these two. Okay, so we're going to have times, I'm putting the y plus 4, y minus 4 on the bottom. And then this was on the bottom, it's going to go on the top. So I'm multiplying by the reciprocal. Okay, so what I did was I rewrote the first one, changed this to multiplication, and flipped it. Now again, I could have done that to begin with and then factored perfectly fine. Okay, all right, so now I'm right here. You can cancel as long as one's in the top and one is in the bottom. Okay, so if you look at this right here, one is in the top, one is in the bottom, so they cancel to give us ones. Right here, a y plus 3 and a y plus 3. They cancel to give us ones. And then the y minus 4s will cancel to give us ones. So the only thing, 1 times 1 times 1 is 1, okay? The only thing we have on top is 1 times that y plus 7. So we have y plus 7 on the top. And we have 1s, multiplying by 1 doesn't do anything. You get y plus 4 on the bottom. And that's it. Okay. Number 15 says simplify. Okay, now the problem with this is mixed up right here, okay? We like our x to come first. Well, all you have to do is factor out a -1. This becomes a positive x, and this becomes a -6, okay? So on the top, this will factor. Again, if you want to, you can do this. However it is that you factor. This is the box method. The AC method was where you take these and you replace this middle term here, and then you factor by grouping. That's fine too. A lot of you do it that way. I don't really care. I don't need to do it. So however it is that you factor. So I'm going to factor this as x plus 8 and x minus 6. Okay, all over -1 times x minus 6. Now, we have 1x minus 6 on the top, and we have 1 on the bottom. Now, some of you are going to write your answer as x plus 8 over -1, and that answer will not be one of your multiple choice because it's not simplified all the way. What you're doing is you're going to divide both of these top ones by that -1. positive x divided by negative 1 gives me a negative x. Positive 8 divided by negative 1 gives me a negative 8. That's the answer you're going to see. Yeah. Okay, it is possible, but I think that's the answer you're going to see. I don't think they're going to write it as when they factor out a negative 1 and they put x plus 8. I don't think they'll do that. I think that'll be the answer right there if it's on your test. Okay, right here, we're going to simplify, raising a power to a power. The mistake that I'm going to see is that you're not going to raise this 3 to the 4th power, and I'll guarantee that answer will be there, okay? You have to say, multiply your exponents. 1 times 4 is 4, times x squared raised to the 4th power is x to the 8th, because you multiply them, times y to the negative 20th. All we did was multiply our exponents by 4. I'll guarantee you one of your answers will have 3 instead of, not 3 to the 4th, which is 81, okay? Now, this gives me 81, okay? 3 times 3 is 9, 9 times 3 is 27, times 3 is 81. This has a positive exponent, so it stays on the top. Negative exponent, it goes to the bottom. Oops. And when you take it to the bottom, it changes that negative 20 to a positive 20. Okay. Number 17, a subtraction problem. Okay. I don't know why they didn't do an addition problem, because they already had a subtraction. Addition are actually, they do have one down here. You just got to be real careful, because with a subtraction sign, everything after that changes. All right, so 17 looks like this. We have x plus 7 over this right here. Now what I'm going to do is it factors as x plus 8 times x minus 7, okay? This factors as x plus 7, x minus 7, because that way it kind of will speed up the thing. So I have x plus 7 over x plus 8 times x minus 7. Minus x plus 8, okay, over this x plus 7, x minus 7. Anytime you add and subtract, you've got to have a common denominator. So we've got to find our LCD. Okay, a couple ways you can do this. The way I taught it is told you to rewrite the first one. Let's list the first one. Now you go to the second one. Anything that's not already over here, you got to list. We do not have an x plus 7 over here. So we've got to list that one as well. The other thing is, do we have an x minus 7? We already have it, so we don't need to list it again. Okay? So that's how I teach it. The other way that I teach it is, okay, what do they both have in common? Well, they both have an x minus 7. So you don't need that one, or one of them. So that is our common denominator, okay, which is the same thing that we have over here. Okay, so we've changed our denominators. This one we have an x plus 8, x minus 7, but we do not have an x plus 7. So we've got to tack that one on. Whatever you do to the bottom, you have to do to the top. So on the top right here, we're going to have x plus 7 times x plus 7. Okay? Over here, we need it to look like this. Well, we have these two, but we don't have an x plus 8. So I'm going to have to multiply the top and the bottom by x plus 8. This was actually similar to one of your test questions when I tested you on this. Okay, now we can write it over one denominator. X plus 8 times x minus 7 times x plus 7. Okay, when you multiply this, you're going to use FOIL. First is x squared, 7x. I'm just going to go ahead and put 7x. I'll just list it all. Okay, so that was that. Now I'm going to say plus 7x plus 49. Okay. Now I wouldn't have done that. I would have just said x squared plus 14x plus 49. Okay. Now, be careful. This is a minus sign. You can't tell because I kind of covered it up with my work. But we're subtracting it. We're going to subtract this whole thing, whatever this answer gives me. Okay? Well, x squared plus 8x plus 8x plus 64. Okay? So, when you have this minus sign, I'm just going to do what I'm going to do it the way I want to do it, which is I want to simplify this one to x squared plus 14x plus 49. It just bugs me with all of these. Minus x squared plus 16x plus 64. All over a denominator of x plus 8, x minus 7, x plus 7. Okay, because of this minus sign, everything's going to change after that. That becomes a negative x squared. This becomes a negative 16x, and that becomes a negative 64. Because I just changed my signs. If you want to, distribute a negative. Distribute a negative 1. Add the opposite. It doesn't really matter. Okay, now I have a positive x squared and a negative x squared. They cancel each other out. Right here, 14x and negative 16x. I'm going to put my answer over here. And I get negative 2x, just in case I need to do some more. Okay, 49 minus 64 gives us negative 15. Okay. All right. Now, I'm just double checking my math. Yeah, okay. All over x plus 8, x minus 7, x plus 7. The only thing you would need to do is double check to make sure the top, you can't factor anything out of the top so that you can reduce it, but you can't factor anything, so you're done. Okay, I'm going to do to number 20 and then I'll stop this video. All right, so number 18. Why I put my numbers on the right hand side of that red, I have no idea. All right, it says simplify. It just means you're going to subtract here and you're going to add here. What we're looking to see is, do you know which ones change signs and which ones don't? This stays the same. 8g to the 4th minus 2. Because of this minus sign, those signs change. Minus 7g squared minus 5. Again, distribute the negative sign, change the signs. That's what I do. Distribute a negative or distribute a negative 1. This has a plus sign, so all of these are going to stay the same. Those do not change because of that plus sign. Now you're going to combine your like terms. 8g to the 4th and 3g to the 4th gives us 11. G to the 4th, I'm not going to have enough room to write all this out. Then we're going to have this here and this here. That gives me negative 11g squared. I'll try to fit it in. And this negative 2 and negative 5 gives us negative 7. Yeah, I was able to fit it in. Barely, but I did. And that's my answer. 11g to the fourth minus 11g squared minus 7. All right, didn't need to do the paper anyway. Right here, I think I can do this right here. Again, the biggest mistake people will make is not raising that 5. So that means 5 to the negative third, because you multiply your exponent, raising a power to a power. This is our third one doing this. It's an important concept. X to the negative ninth. Problem with both of these is they have negative exponents. They're on the top. To get them to be positive, you take them to the bottom. So you have 5 to the third on the bottom here and x to the positive ninth. Okay, the only thing we need to do is simplify 5 to the third, which is 125, x to the ninth power. Now, when you look at the answers, okay, where it's all worked out, all right, it'll be a little bit neater, okay? So I'm only doing it here because I'm explaining it. All right, right here, this is how I would do this problem. I'd go 3 goes into 18 6 times. Okay, side 6. I am going to, because we're dividing, I'm going to subtract my exponent. It's negative 20 minus a negative 5. Y to the 4 minus 8. Z to the 8 minus a negative 4. Okay, this is the only time I change my signs, or double, what I call a double negative. I don't really ever add my opposite except for adding the opposite here. Okay, so I have 6x, this gives me negative 15, y to the negative 4th, z to the 12th. Okay, 6 has a positive exponent of 1, so it's going to stay on the top. This x to the 15 is going, negative 15, is going to go to the bottom, and it's going to become x to the positive 15. Okay, this y to the negative 4th is going to go to the bottom, so it's going to become y to the 4th. And that z to the 12th stays on top. Okay? All right. I'm going to stop right there in this video.